Hello children, you are welcome to this segment of the program, The Classroom in Your Home. It is mathematics time, and that means it is time to have some fun. Hi, I'm Uncle Agbaje. Today in mathematics, we will continue our work on plane shapes. In our last lesson, we examined triangles and different types of triangles. Today we will look at quadrilaterals. Now we look at the learning objectives. By the end of this lesson, you should be able to identify different types of quadrilaterals. You should be able to see them and recognize that, oh, this is this, and oh, that one is that. You should also be able to state the properties of this quadrilateral. If you name a quadrilateral, you must tell us how to identify it. You should be able to do that. Finally, you should be able to categorize quadrilaterals. So let's just move right into it. What are quadrilaterals? In mathematics, quadri means 4. Tetra also means 4. But in this case, you say quadri, 4, lateral side. So quadrilaterals means 4-sided. Now, quadrilateral is another type of polygon. It has 4 sides, as you can see. All quadrilaterals have 4 sides. They also have 4 angles. So we can call them quadrilateral, 4 sides. You can also call them quadrangles, 4 angles. Quadrilateral, quadrangles, whichever one you call them, you will not be wrong, my friend. Now, the sum of all the angles inside a quadrilateral is always 360 degrees. How did you come about this? That is for another lesson, my friend. Now, let's now look at quadrilaterals with parallel sides. And that should already tell you that maybe there are some quadrilaterals that don't have parallel sides. For this lesson, we would only be working with quadrilateral with parallel sides. Quadrilaterals with parallel sides, we call them, the first one on the list is a parallelogram. That's what we call quadrilaterals with parallel sides anyway. You will observe that if I call this point A, and this point B, and this point C, and this point D, then you will observe that AB and CD are going in the same direction. If I extend the line further, they will continue to go in the same direction. The distance between them will always be the same. Do you remember the type of lines that hold this property? They are parallel lines. That is why we call it a parallelogram. A parallelogram is a quadrilateral that has the sides, that has parallel sides, so to speak. So now let's see the properties. Opposite sides are parallel. Opposite sides are also equal. What do we mean by opposite sides? Opposite sides means the sides that are facing each other. Now in this case, AB is opposite to CD. They are looking at each other from the outside, they are not touching. They are opposite each other. If you are sitting in your classroom, the person that you can see directly opposite in front of you is sitting opposite you. Okay, so you can see that person is not by your side. So AB and CD are opposite each other. If somebody were to be sitting here and another person sitting there, they will be looking right at each other. Also, AC and BD are opposite each other. So what we're saying is that opposite sides are parallel. AB is parallel to CD. AC is also parallel to BD. Opposite sides are also equal. That means that AB is of the same length. It's as long as CD. And AC is as long as BD. That's a very important property of parallelogram, the basic property. What other property does it have? Opposite angles are equal. Now again, opposite comes up, but what do we mean by opposite angles? In this case, we are referring to this angle. Now we didn't say interior opposite, mind you. not interior opposite. So this angle right here is opposite that one. So these and these are facing each other. If we are talking about interior opposite, then it will be this one and this one. You remember interior opposite angles where you identify that with a U. Okay, so but we're not talking about interior opposite, just opposite. So this angle is equal to this angle, and as you can see, they are less than 90. They are acute. This one is greater than 90, and this one is also greater than 90. They are obtuse. So this is equal to this, and this is equal to this. What other property does a parallelogram have? It has no line of symmetry. Now let's check that out. A parallelogram has no line of symmetry. Now this is a parallelogram. I'm going to try and fold it and see if we have a line of symmetry. See? Overlapping. They are not equal. That means no line of symmetry there. See? I folded it along this left side, overlapping. They are not equal because they are overlapping each other. You can see this one is clearly showing underneath. So let me see if I can fold it along the angles. If I try to fold it along the angles, what do I get? Now you see overlapping, which means they are not equal. If I turn it again, you see overlapping. This one is overlapping this one. So they are not equal. So whichever way you try to fold it, you will not find a line that makes them equal. So a parallelogram has no line of symmetry, my friend. Now, which other property does it have? The diagonals bisect each other. Do you remember diagonals? They are not vertical, they are not horizontal. So let's look at the diagonals of this parallelogram. A diagonal in this case will join the opposite angle. That's one diagonal. That's another diagonal. Now this diagonal divides this diagonal into two equal parts. This one is equal to this. This long diagonal also divides this small diagonal into two equal parts. This part is equal to this part. That's what it means. So that is that about parallelograms. The most important property is that opposite sides are parallel. That's why they call them a parallelogram. Then opposite sides are equal. Always remember this property. Now moving on to the next quadrilateral. This is a rectangle. You're familiar with rectangles. The top of your table is a rectangle. Your television set that you're watching right now is a rectangle. Your exercise books are rectangles. You see rectangles everywhere around you. A matchbox is a rectangle. The carpet on the floor of your house is a rectangle. It's everywhere. But what are the properties? You should be able to tell me. The opposite sides are parallel and equal, just like a parallelogram. Opposite sides are parallel and equal, so you can see. Now, all angles are right angles. Now, that's the difference between a parallelogram and a rectangle. A rectangle is like a special type of parallelogram in which all the angles are right angles. As you can see. As you can see, the sign for the right angle is here, 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 and in this corner. So all the angles are right angles. What other properties does it have? It has two lines of symmetry. I'll show you that. This is a rectangle, my friend. So let's find the two lines of symmetry. If I fold it along this line, they cover each other exactly. No overlap. No overlap. So this line, my friend, is a line of symmetry. So I'll just trace that out. So you see. So where is the other line of symmetry? If I fold it like this, along the short side, you can see no overlap. If I turn it around, no overlap. They are equal exactly. So this line along which I folded it is a line of symmetry. I'll draw that out for you. But can we find other lines of symmetry? If we try to fold it along the angles, you can see there is a large overlap. And along the other angle, also overlapping. So these are the only two lines of symmetry that a rectangle has. Let's move on. What other property does it have? Again, like the parallelogram, the diagonals bisect each other. I'll just draw that quickly. This is the diagonal, and this is the diagonal, and they are dividing each other into two equal parts. So let's take a look at the next quadrilateral. It's a square. You know squares, you are familiar with them. The top of your Maggi cube is a square. The top of that sugar cube is a square. There are so many square shapes around you. The tiles in the floor on the floor of your house is usually, in most cases, a square. So squares are all around you. You are probably familiar with their properties, but let's just take a look at them. First property is that all sides of a square are equal. I mean, that's why you have equal markings. This side is equal to this side, is equal to this side, and is equal to that side. Let's see. The opposite sides are parallel. So obviously you can say this side is going parallel to this side, and this side is going parallel to this side. It's something you can observe on the tiles on the floor. All the angles are right angles, just like the rectangle. All the angles are 90 degrees. 90, 90, 90, 90. And that is why the total angle is 90 in 4 places. 90 times 4, 360 degrees. It has 4 lines of symmetry. Wow. Well, let's see whether that is true. This is a square. Whichever way you turn it, it's always going to look like a square. In fact, it has rotational symmetry of order 4. 4 times it's going to look the same. But that's not what we're trying to prove. We want to show that it has 4 lines of symmetry. Let's get right to it. I'm going to fold it along one of the sides. Voila, no overlap. And I turn it around, no overlap. So that's one line of symmetry. Let me just draw that for you. Yeah, okay. So now let's find another line of symmetry. I'll fold it along this side. Yes, no overlap, no overlap. So this line is also a line of symmetry. So let me just draw that for you. Okay, so see, very straight. So where are the remaining 2 lines of symmetry? Let's find out. So perhaps if I try to join the corners opposite angles, this one here and this one here. Yep, that's it. See, no overlap, no overlap. So that line is also a line of symmetry. Let me just draw that for you. So where is the 4th one? Well, we can try and join the other angles together. So yeah, that's it. No overlap on this side, no overlap on this side. The 2 shapes on each side are exactly equal, saying that this line is also a line of symmetry. So I'll just draw that for you. So these are lines of symmetry. A line of symmetry divides a shape into 2 equal parts such that one will lie exactly on top of the other and there will be no overlap. So you can try cutting different shapes and finding their symmetry lines during your leisure. So let's see what other property a square has. Diagonals bisect each other. Well, you can see it from this shape. These are diagonal and these are diagonal, and they divide each other exactly into 2 equal parts. Okay, so now moving on to the next shape, which is our final shape for today. It's called a rhombus. Say rhombus? Rhombus. Now, rhombus, you'll find them on the tiles as well. You probably find them in the logo of some companies. Take a note of the spelling. because Auntie Fumi might just ask you to spell it in one of her English lessons. Now, what are the properties of a rhombus? Obviously, these lines indicate that all the sides are equal because they have single markings. Now, opposite sides are parallel, as you can see. This side goes along the same line with this. This goes along the same line with this. Opposite angles are equal. That means that this angle is equal to this angle. They are not right angles, okay? So, and this angle is equal to this angle. What else do we have for rhombus? It has two lines of symmetry. I'll just demonstrate that. Now, this is a rhombus. Looks very much like a parallelogram, but a rhombus has all the sides equal. A parallelogram does not have all the sides equal. So let's find the two lines of symmetry. It's very simple. See? I found one, so I'll just label it for you. So let's look for the other one. Yep. No overlap. So found the other one. So these are the two lines of symmetry. If you try to find any other line of symmetry again, you won't be able to find it, but you can try during your leisure, my friend. What other property does a rhombus have? The diagonals, again, bisect each other. That means these lines and these lines divide each other into two equal parts. So these are the properties of a rhombus. Now for some activity. We'll play the game of which is which. Yorubas call it ewo lewo. Which is which? So, which one is which one? All rectangles are parallelograms, or all parallelograms are rectangles, or none of the two is correct. Think. Are all rectangles parallelograms, or are all parallelograms rectangle, or none of the statements are correct? Well, the final answer is that all rectangles are parallelograms because rectangles have parallel sides. Parallelograms are not rectangles because a rectangle must have 90 degrees on all the sides. And if you look at a parallelogram, the angles rather are not 90 degrees. So this is not a rectangle. It's a parallelogram but not a rectangle. But a rectangle, yeah, it's a parallelogram because it has all the properties of a parallelogram. Take a look at just another one. All parallelograms are rhombuses, or all rhombuses are parallelograms. That one is easy. Is it that all parallelograms are rhombuses, or all rhombuses are parallelograms, or none of these statements is correct? Well, the correct answer is that all rhombuses are parallelograms. All parallelograms cannot be rhombuses because a parallelogram does not necessarily have to have all the sides equal, but a rhombus must have all the sides equal. However, a rhombus has all the properties of a parallelogram. So all rhombuses are parallelograms. And finally, this one. Which one is which? All squares are parallelograms, or all parallelograms are squares? The correct answer should be all squares are parallelograms. This one says all rhombuses are rectangles, or all rectangles are rhombuses, or none of this is correct. The correct answer to this is that none of this is correct. Rhombuses are not rectangles, and rectangles do not have the properties of rhombus. Now we've come to the end of the class. I just want you to copy this down. The homework says you should write two properties for each of the following: rhombus, parallelogram, rectangle, and square. We've written so many properties today. You should find it easy to write just any two out of this. With that, we have come to the end of the mathematics segment of today's lesson. I will now hand you over to Uncle Popo for the basic general studies lesson. Till I come your way next time, remain wonderful mathematicians.